CMB, or the cosmic microwave background, which is the radiation left over from an explosion. But hold on, it's not just any radiation, it's the echo from the mother of all explosions, the Big Bang. The biggest and most amazing boom ever, that created everything we see and don't see. The event that launched the whole universe and also launched some poor particles into oblivion. But hey, how do we know that the Big Bang actually happened? How can we be sure that it's not just a myth, a legend, or a conspiracy theory? Well, that's where CMB comes in. The CMB is like the ultimate proof that the Big Bang was real. It's like the smoking gun, the fingerprint, or the DNA evidence of the cosmic crime scene. It's like the baby photo of the universe. Except it's not cute at all, it's just a bunch of microwaves. But these microwaves are not just any microwaves. They are ancient microwaves. They come from a time when the universe was a baby, only 380,000 years old. That's right, the CMB is the oldest thing we can see in the sky, older than any star or galaxy. Now you might ask, how did we discover this amazing signal? How did we find out that there is a faint glow of radiation coming from every direction in space? Well, that's where things get interesting. Because the CMB was not discovered by some genius scientist who had a brilliant idea and a cool telescope. No, it was discovered by accident, by two guys who were looking for something else and had no clue what they were doing. And that's what makes this story so funny and so fascinating. Alright, let's start from the beginning. The year is 1965 and two guys named Arno Penzias and Robert Wilson are working at Bell Labs in New Jersey. They're using a very sensitive radio telescope to look for neutral hydrogen in space. Neutral hydrogen is a type of gas that emits radio waves at a specific frequency, and it's very important for studying galaxies and stars. But there's a problem. Every time they point their telescope at any direction in the sky, they detect a strange signal that they can't explain. It's not coming from any known source, it's not changing with time or location, and it's not affected by weather or interference. It's just there, constant and annoying. They think it might be something wrong with their equipment, so they try to fix it. They check their wires, their amplifiers, their filters. They even climb inside their antenna and clean it with toilet paper and alcohol. They also notice that there are some pigeons nesting inside their horn-shaped antenna, so they shoo them away and remove their droppings. But nothing works. The signal is still there. They are completely baffled by what it is. Meanwhile, at Princeton University, another team of scientists is working on a different project. They are led by Robert Dicke, a physicist who had a wild theory about the origin of the universe. He thinks that the universe was born with a Big Bang, a huge kaboom that created all matter and energy in a fraction of a second. But here's the million-dollar question. How do you prove it? Well, our cosmic detective thinks that if the Big Bang really went down, it would leave some clues behind, like a cosmic fingerprint. Something that screams, "I was here!" He's talking about radiation, not the kind that warms up your pizza, but the leftovers of a firework on a universal scale. This radiation was the hottest thing around at the start, but as the universe grew, it chilled and stretched. It's like going from a fiery hot dog to a frozen popsicle. So now we have this very faint, very low frequency radiation, like a murmur in the cosmic background. It's like the universe has a story to share, and this radiation is the opening scene. Dicke and his team are building a special detector to look for this radiation. They're convinced that this contraption will be their golden ticket to Nobel Prize glory. Their plan? Find that elusive radiation, the smoking gun of the Big Bang. But surprise! Penzias gets a call from a friend who tells him about Dicke's mission. Penzias then calls Dicke and they have an aha moment. They've actually found what Dicke was looking for all this time. So what does Dicke do next? He hangs up, turns to his mates and says, "Guys, we've been outsmarted." Penzias and Wilson, though, were clueless about their discovery's cosmic importance. They don't know about the Big Bang or the cosmic background. All they see is some odd temperature bump at 4,080 megacycles per second, which becomes the title of their paper, published in July 1965 in the Astrophysical Journal. But here's where it gets interesting. Dicke and his squad drop their own paper right alongside it, explaining the whole cosmic deal. They reveal the truth, saying that this signal is the glow of the Big Bang, the evidence that confirms their universe-making theory. This discovery stunned the scientific community. It was a game changer, one of the biggest hits in physics history. It's like the universe's birth certificate, direct evidence that it had a beginning thanks to a massive explosion. Then Penzias and Wilson become the stars of the show, even if they stumbled upon the truth by chance. They grabbed the Nobel Prize in Physics in 1978. And then there's Dickie and his crew, who get the raw deal. They're not praised, not rewarded, just remembered as the folks who got scooped by a lucky phone call.
I don't want to be late. Arno Penzias was late for his Nobel Prize? I don't think so.
But that's not the whole story. For the last 50 years, astronomers have explored the cosmic microwave background in more depth. It's like peeling an interstellar onion, uncovering the universe's secrets one tearful layer at a time. First, they found out that the CMB isn't just a boring microwave soup, it has some variations. It's not at all the same hot. It's got tiny hot and cold spots. These spots, called anisotropies, tell us stories about the universe's shape and change. They show us how the universe got its shape from those small bumps in stuff and light when it was very young. And they tell us about the cosmic stuff at work. Gravity, dark matter, dark energy, and reionization. They're all part of the show. So the CMB isn't just pretty, it's a treasure chest of universe info. The CMB helped find the Hubble constant, the speed at which the universe is getting bigger. And it even gave us a peek into the universe's end. Will it end in a dramatic crunch, a chilly freeze, or a big bounce? But this cosmic microwave treasure hunt isn't all business. Astronomers used the CMB to look for signs of cosmic inflation, the universe's fast growth in its baby years. They searched for clues like primordial gravitational waves, waves in the space and time that this wild growth would have made. And they didn't just rely on their trusty CMB detector, they brought out the big guns. Instruments and satellites like COBE, WMAP, Planck, Boomerang, Bicep 2, and more. They upgraded their magnifying glasses, making CMB observations more precise and comprehensive than ever. And they didn't play solo. They teamed up with galaxy surveys, supernova measurements, and gravitational lensing to double-check and refine their findings. However, no cosmic journey is complete without some drama. In 1992, COBE bumped into the first ever anisotropies, and some said it was like seeing the face of God. This started a lot of talk about what the CMB meant for our beliefs and questions about the universe and its maker, or not. In 2001, Boomerang rocked the science world by saying that the universe is flat and will keep getting bigger forever. This changed the old idea that the universe was open and endless, and made new mysteries about where it came from and where it's going. In 2003, WMAP gave the universe's age, with a cosmic cake with 13.7 billion candles. It showed that the universe is way older than Earth, the solar system, and even some old stars and galaxies. And then in 2014, Bicep 2 made a big splash, saying they had found proof of inflation in the CMB. They had seen gravitational waves, ripples from the Big Bang's big show. But their bubble popped when they found out it might just be dust in our galaxy making them look silly. You see, studying the CMB is not a walk in the park. It requires a lot of precision, patience, and perseverance. But it's also very rewarding and exciting, because it gives us a glimpse into the origin and nature of the universe, and helps us answer some of the most fundamental questions about our existence. That's why the CMB is not just a bunch of microwaves, but a key to understanding the universe. Speaking of the universe, it's an incredibly mysterious place with a multitude of unknowns. However, when we do stumble upon some remarkable news, you can count on us to cover it in this channel. Before you head out, make sure to visit the channel and get ready to be amazed, because we've got a ton of unique stuff waiting for you, and it's just a click away. And if you want to hear a cliche before you go, let me tell you. Are you ready? Here it comes. If you enjoyed this video, please give that thumbs up button a click, share it with your friends, and become part of our space community by subscribing and hitting the notification bell. I know it sounds like a classic YouTube thing, but it's a big boost for us. Thanks for sticking around. See you soon for more fantastic space videos.